Hello everyone. All right, so welcome back to the good stuff that we have been doing. Today in this video we're going to try to find this sum, or rather show that this sum equals the all of this. Now first of all, we're going to try to understand the terms that appear in this sum. Let's start with the first one. Here you have a factor 1 times 3, 3 times 5, and 5 times 7. Let's put it down. 1 times 3, then you have 3 times 5, then you have 5 times 7. So the first number that appear are numbers of the form 2k plus 1. And the second numbers are the same numbers, but they are shifted by 2. So probably something like 2k plus 3. Now let's check. If k is 0, you have 1 times 3. If k is 1, you have 3 times 5. And if k is 2, you would have 5 times 7. So we have the pattern already. What about the bottom part? Okay, you have 3, 5, 7. Of course, that would same odd number, but this one is shifted by 3. So you have 2k plus 3 because this is the same number, 2k plus 3, 5 and 7. So now we have everything under our control. So this sum, which is 1 over 1 times 3 plus times 1 over 2 to the third power. So 1 over 3 times 1 over 2 to the third power plus 1 over 3 times 5 times 1 over 2 to the fifth power, then plus 1 over 5 times 7 times 1 over 2 to the seventh power. This sum right here would equal, we are going to put this is going to be the sum as k runs from 0 up until infinity of what? So you have 1 over 2k plus 1, and then you have 2k plus 3. Then multiply by 1 over 2k plus 3, 2 to the 2k plus 3. So we can factor out 2 to the third power and write this as 1 over 2 to the third power times the sum as k runs from 0 to infinity of what? You would have 2k plus 1, 2k plus 1, 2k plus 3 times 1 over 4 to the k. And we can put the summand here. We can put this in partial fraction, of course. That is the only way to proceed from here. Usually when you come across this term, by this level, you should be matured enough to try to put it in partial fractions. So that's what we're going to do. We're going to get 1 over 2 to the third power times the sum, 1 over 2 to the third power times the sum as k runs from 0 to infinity of the half of what? Half of 1 over 2k plus 1 minus 1 over 2k plus 3 times 1 over 4 to the k. So we can still do better. This is 1 over 2 to the fourth power times the sum as k runs from 0 to infinity of 1 over 2k plus 1 minus 1 over 2k plus 3, then 1 over 4 to the k power. Now notice, recall some interesting fact here that we know. That fact is that this expression 1 over 2k plus 1, this is equals to the integral from 0 to infinity of e to the negative 2k plus 1t dt. And also 1 over 2k plus 3 is also equals to the integral from 0 to infinity of e to the negative 2k plus 3 t dt. So we have this in terms of integrals now. And the reason for doing that is because is going to really help us to actually sum this, and especially when we have to deal with this factor here. If this factor was not here, probably we may be forced to use polylogarithm expressions, but this factor here is a factor. So let's try to, this is 1 over 2 to the fourth power times the sum as k runs from 0 to infinity of, then you would have the integral from 0 to infinity of what? E to the negative 2k plus 1t dt minus e to the negative 2k plus 3t dt. So now we have two expressions right here. This now we can, like, we have two sums to deal with here. We write this as this is equals to 1 over 2 to the fourth power times the sum as k runs from 0 to infinity of the integral from 0 to infinity of e to the negative 2k plus 1t dt. And the second sum is minus 1 over 2 to the fourth power times the sum as k runs from 0 to infinity of what? The integral of 0 to infinity of e to the negative 2k plus 3t dt. Now let's do this. Let's call, we have two sums here. Let's do them separately. The first sum, which we call our S1. Hold on. So the first sum, which is our S1 here, is going to equal the, let's compute it. The sum as k runs from 0 to infinity. And let's not forget our 1 over 4 to the k power. So let's say this is going to be 4 to the k and 1 over 4 to the k, of course. So this first sum is going to be the sum of 1 over 4 to the k times the integral from 0 to infinity of what? Of e to the negative 2k plus 1t dt. So what we're going to do is that we're going to swap summation and integration and write S1 to equal the integral from 0 to infinity of e to the negative t. Okay, we're going to factor out e to the negative t here. Then we would have the sum as k runs from 0 to infinity of what? 1 over 4 to the k. Then you have e to the negative 2kt dt. So here you would have the integral from 0 to infinity of e to the negative t times the sum as k runs from 0 to infinity of, now because of the factor of 4 to the k, we can write this as e to the negative t, e to the negative 2kt rather, negative 2kt, all divided by, sorry, e to the negative 2t rather, all divided by 4 all to the k power dt. So we recognize this as a geometric series, and we're going to have, this is going to be integral from 0 to infinity of e to the negative t times 1 over 1 minus e to the negative 2t over 4 dt. So this would give us, on the next page, you would have, this is equals to the integral from 0 to infinity of e to the negative t all divided by 1 minus, you have e to the negative t over 2 all square dt. So now we can make substitution. We can take u to be e to the negative, rather x. Let's take x to be e to the negative t all divided by 2. So therefore you have 2x is 2x would be e to the negative t. So 2 dx would be negative e to the negative t dt. Notice that when t is 0, x is going to be half, and when t is 1, and when t is infinity, x is going to be 0. So you would have, this is going to be integral from, this is twice going to be the integral from half up until 0 times what? You have negative dx all divided by 1 minus x squared. So you can switch, you can have, this is twice the integral from 0 to half of what? Dx over 1 minus x squared. And this integral is well known. This is twice of half of the logarithm of 1 plus x divided by 1 minus x. Okay, and we evaluate it from 0 to half. Of course, at 0 this will vanish because you have 1, logarithm of 1 is 0, and also the 2 0 cancel out. So we are dealing with, we're going to deal with the logarithm of 1 plus half divided by 1 minus half, and of course that is logarithm of 3. This is going to be logarithm of 3. So now, when all is said and done, we can see that we are able to find the first sum here. Let's see. Yeah, this first sum here is log 3. So let's find the second sum here. Look a bit tricky, but we can actually do it. So the second sum here, and of course we are removing the factor of 2 to the 4th for now though. So the second sum, s sub 2, is going to be the sum as k runs from 0 to infinity of 1 over 4 to the k times the integral from 0 to infinity of e to the negative 2k plus 3 t dt. So this would be equal to the sum as k runs from 0 up until infinity of, okay, no, we can swap integration and get the integral from 0 to infinity of e to the negative 3t times what? Times the sum as k runs from 0 to infinity of 1 over 4 to the k e to the negative 2kt dt. And just like before, this is equals to the integral from 0 to infinity of what? E to the negative 3t times the sum as k runs from 0 to infinity of just e to the negative 2k 2t rather, all divided by 4, all to the k power dt. So we can now compute this and get the integral from 0 to infinity of e to the negative 3t multiplied by 1 over 1 minus e to the negative 2t over 4 dt. So you would, let's go to the next page. So this would give us the integral from 0 to infinity of, let's say, e to the negative 2t all divided by 1 minus e to the negative t over 2 squared times e to the negative t dt. Let's put it in this way. So this is going to be better for us. Now, what changes need to be made here? Of course, we're going to take association x to be e to the negative t over 2, and just like before, negative 2 dx would give us negative e to the, so it will give us e to the negative t, e to the negative t dt. And then what's the limit of integration is from 1 to, is from half to 0. So this is going to equals twice the integral of half to 0 of what is now you would have x squared all divided by 1 minus x squared dx, negative 2 rather. So this will give you the integral from 0 to half of x squared or 1 minus x squared dx. And then we can do something interesting here. We could write this as to equal, let's put this color here. This is going to equal, okay, there is a 2 here, let's not forget that. This is going to be twice the integral from 0 to 1. You are going to have 1 minus x squared of negative 0 to half. So you're going to have negative of 1 minus x squared minus 1 all divided by 1 minus x squared dx here. Okay, so this will give us negative 2 times the integral from negative 2, let me see. This is going to equal negative 2 times the integral from 0 to infinity, 0 to half rather, of what? 1 over 1 minus x squared over 1 minus x squared. Then you are going to get plus 2 the integral from 0 to half of what? You're going to have 1 over 1 minus x squared. So you have the x over 1 minus x squared. So this is going to equal, let's see, this is going to be negative 2 times, so this is going to be just x, so you have half, so you have negative 1 here, I believe so, because you just get a half. So this part is just negative 1. Then for this part you would have, okay, just 2 multiplied by half of what? The logarithm of 1 plus x over 1 minus x. We evaluate this as 1.5, and the same thing I think is log 3. So log 3. So this is going to be negative 1 plus 2 logarithm of 3. Okay. All right. So let's see. We have the two sums. Let's check, because we have done a lot. Hopefully we did not miss anything here. So let's see. The first one here, the substitutions are right. Okay. Okay. Seems perfectly. Let's check the sum again. Okay, so here I think for substitution case here, e to the negative 2 is going to be, because 2x is e to the negative t, so e to the negative 2t is going to be 4x squared. So we did not bring a factor of 4 here. So we wrote to, okay, so we're supposed to have a factor of 4 here. Okay, good thing we checked. Supposed to have factor of 4. So our answer is supposed to multiply by 4. So we're supposed to have negative 4 plus 8 log 3. Yeah. So let's put everything together now. We have the first sum. So the sum is, we had 1 over 2 to the 4th power times the sum as carried us from 0 to infinity of the integral from 0 to infinity. Sorry, 1 over 4 to the k. So we have 1 over 4 to the k, integral from 0 to infinity. The first one was e to the negative 2k plus 1 t dt. So we subtract this from the sum as k runs from 0 to infinity of say 1 over 4 to the k. Then you had the integral from 0 to infinity of e to the negative 2k plus 3 t dt. So what we're going to do is that this is going to be 1 over 16 times what? So you have, I think the first one was log 3, then you have minus, then you have negative 4 plus 8 log 3 as well. Okay, so okay, no, this is not 2 log 3, this is not 2 log 3, this is just log 3, so this will just be 4. This is just 4. Okay, so this is just 4 here, to be sure. So this is just 4. So you have 1 over 16 times so log 3. So you have 4 minus log 3 minus 4 is 1 minus 4 is negative 3. So that is 3 log 3. So you have 1 over 4. Yeah, 1 over 4 minus 3 over 16 log 3. So wow. So that is that. So we have conquered this problem, and this is our answer. So thank you for watching, and please do subscribe to the channel. Bye.